This is the prep packet video for Unit 4, Chapter 9.3. We'll be looking at Objective 2, in which we simplify the square root of a whole number. So basically, what we'll be doing is we'll be taking a large number and breaking it down into parts. Just like we were able to build up using factors, now we're going to take apart using factors. And if we start with a basic square root, that we know is a perfect square. So I'm going to say the principal root of that would be 5. But what if I had this? I would have to use my product rules to take that apart. So that's the same as 4 times 11, right? Those are the factors of that. Now we have to look at them and say, are any of these perfect squares? And in this case, we have a perfect square, and 11 is not. So we get to take the square root of 4 times the square root of 11, and we'll end up with 2 square root 11. Please notice that we no longer put a times anything that it says multiply, because since they're smooshed up next to each other, that means they're multiplying. Now, the thing you have to do is that make sure that inside the radicand, you want to make sure that there's nothing left that is a perfect square. You can't have any fractions. You want to take care of that. And you can't have it, so we don't want this. We would rather have this. Oops. And then number 3 says there's no radicals in the denominator of refraction. And we can take care of that by multiplying, just like we would do with any fraction. We can change it how it looks by multiplying it by 1, but that doesn't really change the actual value. So remember, the same thing over the same thing is still 1, right? So here we'll have the square root of 3 times 5, which is 15, over the square root of 5 times 5, which is 25, and that is a perfect square. So we're going to leave 15 alone, and that's what that will look like. So that's what we're talking about, that it doesn't have any factors that are perfect squares. Like over here, we took care of this. Number 2, the radicand, that's the part inside, does not contain any fractions, so we took care of that. And then number 3, we made sure that there were no radicals in the denominator. And after you work on it for a while, you want to look at it and ask yourself, is the radical in the simplest form? If it's not, keep going and do it again. If you, like I say, asking yourself this question will help you make sure that your radical is completely simplified. I think the best way to take a look at this, though, is to sort of work on a couple of them. So let's take a look at this. Our first one that we're going to do is the square root of 45. And I know that the factors of 45 are 5 and 9. So I'm going to do this. The square root of 5 times the square root of 9. This is a prime number. It's not a perfect square, so it's going to stay the way it is. However, 9 is a perfect square, so we can do some more here. So I'll end up with the square root of 9 is 3 times the square root of 5. And the 5, again, is taken down as far as we can go. And remember, we're going to put them both together, no little signals in between, because we know this, just a sort of a side note, we handle radicals the same way we would handle variables. You wouldn't write this, you would write this. Okay, so let's take a look at 72. And sometimes with these bigger ones, it's hard to recognize the perfect squares. So sometimes you might have to do a little factoring here. So here's 72. It's even, so I know it's divisible by 2. 2 goes into 7 3 times with 1 left over. 2 goes into 12 6 times. Oh, and that's a perfect square. So I know that 72 is the same as 2 times 36, the square root of 2 times 36, or I can take this one out, so 6 root 2. And if you are unfamiliar with this method of finding factors, I would suggest you look at the video in today's work called Finding Primes. Okay, let's take a look at some more. Here we have the square root of 12. And again, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. I could use any of these. It will just take a little longer to break them down. But I'm going to go right for the thing that has a perfect square in it. So here I'll have the square root of 4 times the square root of 3, which is the same as 2 root 3. Here we have another one, and the factors of 15 are 1 and 15, 3 and 5. Now this is a little bit different because up here we had a perfect square that we were able to deal with. But here the factors of 15 are both prime, and you're not going to be able to do anything with that. So that's just going to stay. You could write it like this if you wanted, but this is actually the preferred look at the moment. So again, what I'd like you to do now, if you need more practice on this, I completely suggest that you do, actually I don't suggest, I ask that you do the U-tries on page 537. These are part of the assignment, so include your work with the prep packet. And again, if you need help finding prime factors, I've attached a video made by our own Laura Stone, and there's a link to it in today's section. And we'll see you in the next video. Thanks.